This week's episodes were brought to you by the generous support of Yukofin. Right now, so that's not quite right. It's moving towards 0 towards both poles. So y going positive, we're moving north, and this is correct. But y going negative, we're going south, and we actually want the numbers to get bigger here. I think we might want vector 3 dot forward. Let's try this, and then we might have to offset things by 90. So that gives us a latitude of 0. If we go upwards, it goes to 360. If we go downwards, it starts to grow. If I just take this and say minus 90, and that's not quite going to work out, but it's going to get closer. I think we got to deal with the looping. So if I go positive, why are you stuck at minus 90? Oh, I think I was messing. I think there's a bit of a rounding error. Is it because it's not a float? I don't see why that would be. Okay, if we go negative, then it's starting to look right. No, it's not. Let me think here. Let me think. Let me switch back to look rotation and consider this. I think from 2 will ultimately be more correct, but I'm just out of curiosity here. So right now my ship is on the equator, and that's a 0. There we go, and we're just looping around. Now that's right. Yeah, because if I'm going negative, so positive, we've got this. What I'm going to do is put in a little check over here. Again, I don't know if I'm going to be completely happy with things. Let me make a private float. I may have to take another approach, but float latitude. So we're just going to correct things to the orientation we'd be probably most comfortable with. So this is just going to return underscore latitude. This over here is going to set latitude to the past value. So right now, if we go north, it's going to 360 and growing. So if latitude is ever basically greater than 90, or whatever, I mean, it sort of doesn't matter what value we pick there, then what we want to do is we want to take the latitude equals latitude minus 360 for 1. So this is going to give us negative numbers that climb as we get closer to the North Pole, which isn't actually exactly what I want. But no, that's okay. And then if we were right at the North Pole, so if, you know, y is anything positive and z is equal to 0, we get minus 90 there. Oh, let's say minus 270. There we go. That makes sense. Because we can actually check that, right? If we start off... Yeah, I could have checked this beforehand. But if we have a positive y, z is equal to 0. Oh, 270. Greater than or equal to 270. There we are. And just let me reset this so that we are directly over the North Pole, like this. So this should be telling me 0 in the coordinate system that I think I would prefer. And then as we move off of that and now move downwards towards the equator, if I go actually to the equator, we've hit 0. There we go. It works until we get there, and it should keep climbing. Let me get rid of this math. There we go. Hold on a sec. Let me get rid of this completely and confirm what our value is when we're at the North Pole. My bad, you guys. Sorry about this. Yeah, that's fine. If I'm at the South Pole, what are we looking at? Oops. Oh, right. Yes. Okay. If we're at the South Pole, then we sit at 90. So what we want is if it's greater or equal to 270, we do want to remove this. Else if latitude is greater than 0, then, so this is, we are north of the equator. I'm going through a lot of work here to sort of like normalize something that maybe I don't need to. We are south of the equator. So we actually just want to add 90. Greater than or equal to 0. There we go. So now we're at the North Pole. We have a latitude of 0. If we go to the South Pole, we have 180. If we go to the equator, which we can do by making this 0, we are at 90. And then if we go just positive, it's going to get smaller as we go towards the North Pole. If we go negative here, it'll get bigger as we go towards the South Pole. That's, I think, the coordinate system that I'm looking for. So sorry we had to sort of like goof around there to get that. Math is annoying, and I screwed up a lot. I still think we're going to end up switching this to a from-to rotation later on when we deal with tilted axis planets. But for now, this is going to work just fine. So we've got that. The longitude should be okay, except with the question of where is our prime meridian. So right now, let's switch this around so that we're at the equator, just to say. And so if I bring it to like negative 5,000, this is bringing it towards the camera. It's saying our longitude is 180. So actually, we'll set it to positive 5,000. We're at longitude 0, which is fine. I'm totally okay with that. So basically, if we look down, right, our ship is here. So right over here on this side of the planet is our prime meridian. So if we do this and this, we are now looking at the prime meridian. Let's pop out of here and rotate the light around so we can actually shed some light on the 0 prime meridian. Now, I'm not going to change the math for calculating the prime meridian, okay? Because this is perfectly fine. The prime meridian should go, should be a 360-degree thing. Or is it? As I take the ship and move it towards the X, certainly we'll go positive. If I go, say, 5,000 and get rid of the Z aspect, we're now at 90. If I were to get rid of the X and put the Z at minus 5,000, we're at 180, so we're on the back side. That's 180. That's correct. Now, the big question is, if I set the X to minus 5,000, and that's 0. Okay, it's 270. Great. Okay, so it is correctly doing a 360 degree around the planet, which is exactly what we're looking for here. That's good. So the only question is, this is the 0. This is our prime meridian over here. And is that a sensible location? Well, let's try to figure out, based on our topographical map, where the hell this is. Right here. You see this crater here? Right? You've got quite a distinctive little blast pattern, right? It's got the crater and then it's got a darker area around it. It is right over here. So right along here, this is our 0 prime meridian. And this is our 180, I don't know, anti-meridian or something like that. Which is, I mean, it's fine, right? It's totally arbitrary. Why is Greenwich our place? For our purposes, it would be really handy if the prime meridian, the 0 spot, was right, I think, on the seam over here. If 0 was the left edge. So there's a couple of different ways that we can resolve this. We can math it by literally just going, minus 90 degrees or something like that. But the visual painting of the, of the texture lining up with the world coordinates is kind of sort of arbitrary, based purely on the UV coordinates of the mesh. If we bring in a different mesh for our sphere, it'll have, it can line things up in a completely different way. So ultimately, this is going to be a situation where what we want to do is this. We want to take our moon, right-click on it, create empty inside the moon. That way we have something at the same position. And then I'm going to take this game object and move this out. I'm going to take the old moon and move it inside this game object. The moon is going to be renamed to Moon Graphics. And the game object will be renamed to Moon. We then have to remember that our canvas here, the text, is pointing to what is now moon graphics. So we want to point it to moon. And then all I want to do is the moon graphics, I want to rotate it, I guess 90 degrees around the y-axis. Is that the correct seam now? Because I want it to be right over here. That, to me, looks right. Because, right, our seam's going to cut right through here, right? Look at this quite sort of shallow crater here and then 2 craters over this way. We can see the twin craters there. And the shallow craters that we're cutting through right over here, you can see the fringe of it here and the rest of the fringe of it on the other side. So there we go. So now we have the seam lined up with our 0 longitude. And between these two things, it should make the next step supremely easy. The next step is to get the texture UI coordinates to work properly. Let's take this text and actually shrink it down a bit because we're getting some line spillover. Although that's still the case. You know why it's the case? It's because our spherical coordinate here is too wordy. Let's me grab, because I don't know how, like, the keyboard shortcut for it. I'm just grabbing just copying the Unicode symbol for degrees here. All right, so there, degrees, like that. So what we want is we want this formatted how? I guess I want a string called lat string, which is going to be equal to, say, another string.format, just for whatever. That's fine. Is going to be equal to some number degrees. Yeah, but this value is a little interesting. I'm tell you what, I'm just gonna default this to 0 degrees. And because what I'm gonna do is I'm gonna go ahead and convert this to the classic Earthicorn visual format, just so it looks fine on screen, even though internally we're representing things differently. Because that's not gonna be confusing at all, right? So what we want to say is if latitude is less than 90. Yes. Because if it's exactly equal to 90, we want it to say 0 degrees. If it's less than 90, north. So, I mean, we're going through a lot of trouble of, like, converting back and forth, but may be wrong, but I think it's going to make our life simpler going forward. God, I hope I'm right. So here we actually want to update lat string here to say some number degrees north, where the sum number of degrees is going to be equal to latitude minus 90. There we go. So right at equator, this would return to 0. Right at the North Pole, or wait, hold on. Other way around. So right at the North Pole, now this would return a value of 90. Right at the equator, it would return a value of 0, because internally latitude at the equator would be 90 degrees. There we go. So we've got that. And then, boop. Else if latitude is greater than 90. Again, we're not testing for 90 because that's exactly 0 degrees of the equator. This, we're on the south side. So degrees south. So in this case, we want, I think, latitude minus 90, right? Yeah, that one's a lot simpler because at the south pole, latitude would be equal to 180. 180 minus 90 is 90, which is the number we want it to return. So that's good for that. This is going to be 0, 1, and we're just going to have lat string, and then we're going to do a similar thing for the longitude string. And for this, we want to, so first of all, what's the east? Well, so if longitude is less than 180, then we can just use the value as is, because if as longitude increase, we are indeed going to the right, which is indeed towards the east, right? So we can say blank degrees east, which is literally exactly equal to just longitude as is. That's fine. If it's greater than Actually, if it's equal to or greater than 180, then it's west. I guess the question is, I'll tell you what, less than or equal to. So if we're at exactly 180, we'll call it 180 east. Otherwise, if it's greater than that, then we're going west. Where we have to do what? So as we go further to the west, the internal number gets closer to 360 degrees. So what we want to do is we want to take the longitude minus 180. So now it's going to go from 0 to 180. But we need to invert it. So we take that and do this. And I don't think we need more parentheses, but I like parentheses for clarity. So we're going to do this. So this bounds it to from 0 to 180. That inverts the logic. So that's the west side of it. And we put those two in there. So now it's going to be in the sort of standard Earthican style if we hit play, which is different from the way that it's displayed, but that's okay. So now our ship is, right, that is correct at 0 degrees. My bad. And it still says east for 0 degrees. Really? Right, because at 0 degrees it would do this. So if longitude is equal to 0, then do nothing. Else. I mean, the second else isn't actually required, but the first one definitely is. Because it should say 0 degrees, 0 degrees. Excellent. And as my ship moves slightly to the east, there we go. We go slightly to the east, slightly to the west. There we go, slightly to the west. There's a split second there where it was showing a negative number. The reason for that is this equality here. This number did not exactly resolve to 0. So I think, and this is a thing that happens with floating point numbers, we're going to put in something like if it's less than or equal to 0.01f, we're just going to list it as 0 degrees. I think that's a very tiny, very unlikely bug that's going to come up. There you go. So there's that little slight window where it's still listing it at 0 degrees before it breaks. We can probably go and do something like this. Like it's infinitesimally small where you've got that weird floating point comparison issue. There you go. And it's only being weird because we're actually so far away on the z-axis that these tiny microscopic x doesn't make much of a difference. But there we are. And eventually it would wrap around. So we've got our spherical coordinates in the standard Earthican style of, blank degrees east and west. We're not saying minutes and seconds because that is an idiotic system. But we've got that. Whereas internally we're representing things in a very useful, just 0 to 360 degrees and 0 to 180 degrees. That then we can map to the next step, which is the UV coordinate. Which I guess I can keep going. This episode clearly is going to have to be split by 2. You're probably in the second part of this episode. So this was started as episode 6, so I must now be in episode 7. But yeah, sure, let's just keep going. So the UV, texture UV is, I guess we'll have another coordinate helper. Public static. And this I think we really can return a vector to, although for consistency, we might decide to make another, like UV coord or texture coord kind of helper. Let's just make the vector 2 for now, and we'll see. So here we're going spherical to UV, I guess. So this will require a spherical coord called sphere coord, and we'll return a vector 2, which ranges from 0 to 1. So let's think about this. This is where the previous little work that we've been doing has paid off, in that we've got a relatively sane sphere coordinate system with the 0 to 180 kind of range, right? So what we want is what? Well, I'm not sure, but I think it goes linearly from the top to the bottom. So I think, 0 degrees, 90 degrees, 45 degrees right in the middle, I think is how this maps. So really, new vector 2 UVs, or UV, is equal to new vector 2. I think for the y component, we can literally just say sphere coord dot latitude I think it's confused because I've left that other area blank. Divided by 180 degrees. So this will range from 0 to 1. We probably need some validation in here to make sure that those numbers don't exceed those bounds. I mean, we're doing a little bit of checking here, but let's worry for that another time. Now, that I think is very straightforward. The problem is the horizontal direction. We, to start off with, could say sphere coord dot longitude divided by 360 degrees. This feels right. Actually, this is. It's another place where we have to consider, okay, what am I talking about? Return UV. What I'm talking about is the fact that when you look at this planet here, right, the diameter of the planet is the full diameter here. So in case of the moon, it's 4,000 and change kilometers, right? But if you keep taking slices horizontally like this, the diameter of the chord or whatever, the sphere or the circle that you get from these slices gets smaller and smaller and smaller. And as you get to zero, as you get to the pole, it approaches 0. Basically, what is the sign of 0 is 0, right? Yes, okay. So basically, we would be taking the latitude, so the sort of horizontal diameter, the diameter of this cut here, is equal to the full diameter of the moon times the sine of the latitude. So as your latitude approaches 0 at this pole, the effective diameter reaches 0, and the same thing happens at the bottom. That's going to be important for mapping from our, when we create our train bits. That's going to be very important. But is this just wholly correct? Yeah, I guess for this it is. So what we're going to do back over here is we're going to do vector to UV chord is chord helper spherical to UV, where we just pass in the sphere coordinate like this, and we say texture UV is equal to UV chord dot string. So right now our ship is at the equator, directly ahead. This should actually return a UV coordinate of 0, 0.5. That is correct, because where the ship is lined up, which is here at the front, right? The ship is currently aligned exactly with this point. It's hovering several thousand kilometers above this point here, which is right here, because we're on the prime meridian. We're in the 0 longitude, so the x will be equal to 0. And we're on the equator, which is halfway down this texture over here, so that's a 0.5. That is correct. If we take the ship and we move it to hover, say, above the North Pole, then it's going to return a texture UV of 0, 0. And that should actually be... That's quite interesting. Because right at the North Pole, it's true, it's sort of like an infinitely small point, so it will always be 0, 0. Whereas if we were just slightly shy of the North Pole, which would be done how? I'd have to give us just a little bit of movement in one direction, okay? We're just slightly off the North Pole at this point. Because if I set this 5,000, we should be 45 degrees off the North Pole. Oh, there it comes. Okay. Yeah, I guess it is just a really small change. And so we're doing... I wonder... Okay, we need to know if this is correct. Right now, with this, again, with no x thrown in. So as we throw in some x, we go here. How would I end up where I want to be? Let's say I do 5,000 and 5,000. So now we'll be at 45 degrees east. It's interesting that, yeah. How do I get to 45 degrees north here? Oh, it would be, yeah, it's not going to be 10,000. It's going to be the hypotenuse, right? Which is some value of things that I'm not going to be able to calculate in my head. So, awesome. There we go. We're getting pretty damn close. So, I mean, does this sound right? That this should be 45 degrees? No, it can't possibly be. Why is it 40? Why would it make a difference, the Z portion of this? I think one of my things in my rotation is off. I think it was fine when I was only looking at 2 planes, but now that I've thrown in the third one, I think it's incorrect. Or, you know what? No. You're right. Yeah, that is about 45 degrees now that I've oriented this view correctly. That looks like it's about 45 degrees-ish. Okay, good. Excellent. Wonderful. Right, of course, because we're further away than I was giving you credit for. Because, again, yes, because of the hypotenuse. Excellent. Math. God damn it, it's going to kill me. Okay, so the question being, then, is the coordinate system actually 100% accurate at these points? So I guess the thing to test is, if I zoom into here and try to get that lined up with the origin of the world. So the origin of the world passes through here and here. That's roughly lined up. I am not on anything particularly significant. So can I line it up? There's probably an easier way to do this. Okay, what I'm going to do is I'm going to line up this crater to be what looks like the origin of the world here, and then just put this over that, which is probably going to require... Where the hell are you? There it is. So that seems to be lined up with all the axes, right? Yes. So the question is, it's telling me the sphere, the texture UI is 0.1, 0.3. So if we look at our texture and consider 0.1 on the x is not going to be very far this way. 0.3, about a third of the way down. Is it just me, or is this crater this one? Yes, it is, with this one over here. Is this actually like 0.1 degrees off the right side? I think we've got a mirroring going on with our UVs here, because this feels kind of right. That imagine that this was 0.1, so 10% away from the right side is about here, and 30% of the way down the top is about here. If this is 50%, 40, 30, 20, 10-ish, it's the whole, this is a cylindrical projection. I think it's vaguely right, except for the it should be 0.9. All right, well, let's figure this out. If I were to take the ship and let's say I throw it on the negative side over here. There we go. So now we're at 0.9. So the ship, if I find it, is now hovering vaguely over, I don't know, next to, next to these two craters here, right? See these two little guys here? If we look at our topographical map, though that pair is it these guys? No. Yeah, I suspect that there's a little bit of a flaw. So what I'm probably going to have to do is take some time between episodes and crunch those. The bigger craters are usually easier to find the signatures for. Okay. No, you know what? Maybe we are right. You see this pair, this set over here? It's a somewhat medium-sized crater that's got a small crater that's part of it and a couple of small craters next to it. That's this spot over here, which means that this spot here is just below that. Oh, I think there we go. It's this stuff here. Yeah, it gets distorted with its projection, right? But like these two sort of shallow medium craters are these shallow medium craters, and it's got a somewhat darker small crater here, which is this one here. And this pair of craters here is this pair of craters here. So it's telling us 0.9, 0.3. Again, I think the height is good because we're right around here, the 0.9. So I think what we need to do is just because, and this is partially because of how the image is being rendered, I think all we want to do is invert the x. 1 minus that will get us where we're happier with our positioning of things. So our ship right now, again, is just forward, so its coordinates are returning as a 1.0, which we could clamp to a 0. It's exactly the same, right? 1 and 0 is the same for the texture, so that's fine. Okay, I think that is now correct, and that's going to be very important for the next episode, where we're going to try to generate the correct terrain for the spot that the ship is under. And in particular, it's going to hopefully deal with this over here, because one of the things when we generate our terrain, right, where's this going to matter? In dynamic terrain, there is a bit where we pull the texture right here. We're pulling the texture, and we're using X pause, Y pause based on the rectangle. Well, this X pause and Y pause is really the UV coordinates of the texture we're pulling. And we're going to have to get these UV coordinates based on these spherical coordinates, and it's going to have to be pulled at every tick as we go through this, because it's going to wrap and line up in very different ways. So we're going to need to be able to convert from the position here. So this Y pause and X pause represents the position of the terrain. So we're going to have to convert from this to a spherical coordinate based on all kinds of things, and then map that to the texture coordinates based on how we're zoomed and different things like this. If you thought my math in this episode was bad, wait until you see the next one. Thanks for watching. See you next time. Hey, I want to give a big thanks to all the January Patreon supporters, and these Mic Check supporters: Yukofin, Snoopy TRB, Pavel Zdanov, yeah, Drazion, Jan Torivel, Michael McClintock, Aaron Toibson, Craig Mortel, The Not-So-Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Steven Stager, Valiant Cakefeed, Wes Oldenbeving, Michael Knudsen, Jason Yanity, Stephen Bonnerman, Kale the Quick, Neil Blakey Milner, and everyone who has watched, shared, favorited, and subscribed to this series. Thank you very much.